Maybe I might make it available on video, possibly, we'll see. But just, if you don't stand here, you won't be in the video. You're all good. So yeah, so make sure you ask questions in class, ask others for help, to understand, not just what do I do next, right? Which means that if you're explaining, don't just say, oh, do this next, do that next, right? Make sure you're explaining to them so they understand it and can do it on their own, which is better for you because remember, when you explain it, that helps you create a clearer mental structure so you can recall it yourself better. All right, in-class labs and quizzes, those are really similar to exam questions. Who actually did the practice exam? Great. The best way to do it is do the practice exam first, then check the answers. Because if we look at the answers to figure out how to do it, then we're like, oh yeah, that makes sense, right? But then when you get on your own, it's a lot harder. So that'll give you an idea what you need to study and work on. Also, we have in the math lab, which is 601, we have drop-in help various times of the day, and also the tutorial center, 2401, just right around the corner. They have drop-in hours there for help and help. The other thing is when you do your homework, one thing, do your homework, right? But two, don't just rotely follow the show me how to do it. Because it's not about can you follow directions, it's about learning how to do the material so that when you get to the exam, you get to see that again. Have we talked to you guys about the curve of forgetting? Yeah. Yes? Who's heard of the curve of forgetting? Who's never heard of the curve of forgetting? Okay, curve of forgetting works like this. They've done this research. And when you learn something, you remember it pretty well for like, yeah, maybe like 5 or 6 hours. But like the next day, you've forgotten maybe like 40% of what you learned, right? If you wait like a week later, you only remember like 10% of that or less of all that. And you're like, what? What was that? But if you just spend like, after 24 hours, if you spend like 5 minutes reviewing what you learned previously, then all of a sudden, boom, you remember it all. And then it takes you longer to forget that. It takes like a week before you kind of get down to that 40%. And then just 2 or 3 minutes, then boom, if you're reviewing it, you're back up. So that would be maybe doing your homework then. And then after like 30 days, maybe before the midterm exam, it just takes you a couple minutes to remember it. If you wait, so that's like 5 minutes, 3 minutes, 2 minutes, 10 minutes total, right? If you learn it here and you wait until before the midterm exam to study it, you've got to learn it all over again, and it's going to take you half an hour instead of that little 10 minutes, a little bit here, a little bit there, a little bit there. You know, you guys, you know what I'm saying? So one of my colleagues, what he does with his computer science students, he tells them just the next day when you're eating dinner or whatever, just flip through your notes as you're eating and just kind of spend 10 minutes, 15 minutes kind of looking through it all, because the lecture is kind of longer, so maybe 10 or 15 minutes, just kind of browsing through that. And then a week later, you know, when your homework's due, when you're doing it then, it kind of gives you another refresher on doing it. Also, my math lab has really, they have videos for everything that's in there, right? This textbook, the videos are okay. They're not great, but they're there, and they're better than nothing for sure. And it's definitely the way the book teaches it as well, which is useful. But you've paid for this program that includes those videos, right? That's part of what you're paying for. So take advantage of them and watch them if you need extra help on that. Let's see. Oh yeah, and last thing is, we talked about this before, this is all brand new stuff, right? So it's super, super common for people to need to take this class more than once, twice before they pass it. So yeah, I think if you're getting like 40% or more on the exams, then stay with it, keep working hard, and I think next semester you should be able to pick up the rest of it. If you are scoring less than 40%, say like you're like less than 30% and things getting confused, maybe talk to me, because I'm thinking about starting a little study session Tuesdays and Thursdays from 3 to 4:15 in that 601 to kind of go over a lot of the basic stuff from chapters 1 through 6, and we can kind of try to pick up some of that extra stuff. All right. I am handing back the exams today at the end of class. And again, it's only worth 50% of your grade, right? It's worth less than the participation of this class. So just Keep working hard. All right. Chapter 7. Everybody has their handout? You guys, we had a whole bunch of A's. We had a kind of a large number of F's also. So didn't pass. You're not alone. There's a group in there, and then like not really that many kind of in the middle. It was kind of mostly those two spots. No worries.
That's hopeless.
Okay. You guys have like 30 seconds just to kind of chat and debrief. I think 30 seconds is fine. Go ahead. All right, but one thing is, you guys don't miss class. Don't be sick. Don't share. Someone says, "Hey, try this." Say, "No, Ms. Young, my stat instructor says I can't." Don't get sick, right? Wash your hands. Get enough sleep.
I'm showing that.
Eat meals. Yeah. No, seriously. Okay. All right, you guys, let's go to one. Let's get a reader. Brendan, go ahead.
Why do we take a sample?
And one more.
What are polls for?
Great. So guys, why do we take a sample? Anybody?
To get an estimate number or prediction
To make a prediction,
Yeah.
right? Anybody else have something they want to add?
Because it's too hard to do the whole population.
Right. We want to make a prediction without asking everybody, because we pulled everybody. It would cost a ton of money, right? That's not really useful. So usually we take a poll and then we kind of find out. We guess. We make an estimate of what everybody thinks based upon our sample. Good. What is proportion? Oh, sorry. Go ahead, Brendan. Keep going.
What does a proportion look like? Where does it come from? What kinds of questions did the researcher ask subjects?
Great. So I want to take 30 seconds with the neighbors trying to figure out what kind of question, not what am I asking you, but if you're a researcher and you're asking somebody, what kind of question are you asking them for a proportion? 30 seconds.
Wait, for the proportion? Like proportion is kind of like the population, the part of the population, right? Low fat. Hey Pam. Yeah, it's like a part. Do you think the proportion is kind of like the population of the survey?
Yeah, it's a proportion of, it's a part of,
Because that's what I was thinking, but I wasn't sure.
All right. Who has an idea? Yeah.
I would ask for age, gender, and where they're from first to identify their background.
Okay. So, I see what you're saying. So you wanna know. So what you're saying is, what would you want to know information about them? Okay, that's true. It's good to know information about them. My question is, what kind of question, like to get your data, would you ask for a proportion versus a mean?
If you're trying to get a numerical proportion, you should probably ask a quantitative question.
Right? So numerical would be, so numerically you'd ask a quantitative question. Proportion, what's an example, what's a proportion look like? Someone give me an example of what a proportion looks like.
like a part of something.
A part of something like what?
Like half of the population.
Like half the population? Or did you have something else? You're raising your hand also?
I think like a question like how many days a week do you watch TV?
How many days a week do you watch TV?
Like 3 out of 7 days.
For me, it's all 7.
Right. Okay. All right.
But I
All
get my
right.
homework done.
Okay. Well, let's look at the first one. Trump has a 41% approval rating. That is what we call a proportion. So when your kind of your summary is a percentage or a percentage in disguise, then that's what a proportion looks like. So, do you guys remember way back when we did, we were doing frequency tables and we had we had probability with blood types. We had like O blood, A blood, B blood, and AB blood. And we had that thing of like, what's the probability someone has O blood? And it was something like, well, we kind of looked at our survey and said, oh, 21 out of 50 had O blood. So 21 out of 50 was our probability. That's a proportion, 21 out of 50. Yes?
So just like a percentage or?
Yeah, so proportion is going to look like a percentage or a fraction. It's going to be like 3 out of 5 dentists recommend Crest. That would be a proportion. So, and with that in mind, what kind of question am I asking somebody?
Mutually exclusive.
That they would be, the answers would be mutually exclusive, that's true.
A yes or no question?
A yes or no question. So I might be like, you're a dentist, do you recommend Crest? Do you recommend Crest?
Yeah.
Do you recommend Crest? Do you recommend Crest? Yeah. Okay, so those are going to be yes, no questions, right? That makes a proportion. A mean is different. That's when your data are numbers. So if I said, how old are you?
18.
How old are you?
18.
How old are you?
Makes sense.
How old are you? Those are numbers. You're not going to ask somebody how old are you and they're going to say yes. So when the questions that you actually, your data, the questions you're actually asking somebody, those answers are yes, no answers, or isn't answers. That's what makes a proportion. You guys remember binomial? Right? Only 2 possible answers. That's where this proportion comes in. When we have a numerical, our data is numerical, that's going to be a mean, and we'll talk about that next class. Let's get someone reading this one. Rachel, go ahead.
A point estimate is a single value or point used to approximate a population parameter.
Great. What's a point? Anybody know what a point is? Maybe I have a. What's like if I draw a point, what am I drawing?
I'm done.
One dot. If I draw it on a number line, what am I drawing? Just one dot. So, I gave my sister this birthday card. It said, you'll win $1 million if you guess the number inside this card. I'll give you a hint. It's between 3 and 5. What do you think she guessed?
4.
4. Right. The actual number was like 3.7246197. Right. A point is just one tiny spot, right, out of all these other numbers. So this point estimate is just one number, one single number that you're picking to approximate. So here's a definition that you're going to need. Caesar, go ahead.
The sample proportion.
Oh, so that's P hat. It has a little hat on it. So P hat. Go ahead.
The sample proportion P hat is the best point estimate of the population proportion.
P, and then that's P. That's a little 0. That's P naught. Who's ever heard the phrase "all is for naught"? It's like an England sort of thing.
Yeah.
Yeah. It's like spelled N-A-U-G-H-T. So all is for naught means all is for nothing. So naught means nothing, 0. So population proportion will either be P naught or it'll just be plain P. It'll be one of those 2 things. Okay, so often we'll just use plain P, but it also could be P naught. Keep going.
The population proportion P naught. The sample mean X bar is the best point estimate of the population. Mean.
Good. Great. So in other words, my best guess at what the population is whatever I find from my sample. If I poll a bunch of people, 100 people, and 41% of them support Trump, my best guess of the population, everybody who supports Trump, is going to be what? 65%? 41%. Whatever I get in my sample, I took a sample to make an estimate. So my best guess is whatever I got in my sample. if I sampled all of you guys here and found out your heights, and found your average height of this class, what would be my best guess of all the heights, the average height of all Las Positas students? What would be that? All right, take 15 minutes, 15 seconds, talk to your neighbors. I sample you guys and average your heights. What's my best guess for the average height of Las Positas students? Ian.
Yeah, it wouldn't be accurate.
Whoever's not talking is who I'm most likely to call on.
Yeah, it would be like the average of the class, but it wouldn't.
No.
Our mean height, what would be the best guess?
What do I have? All I have. All right, so you guys bring it back real quick.
Or P hat or.
If I sample all of you, I take your average height. Your average height ends up being 64.3 inches. What's my best guess for the average height of all Las Positas students? 64.3 inches. Does that make sense? So what I get from my sample is my best one number guess for my whole population. Does that making sense now?
Yeah.
So this is what I don't know. This is too hard to find because I'd have to ask everybody. That's super expensive and takes a lot of time. So I take this sample, and that's my best guess at what this is. Same thing with p hat. P hat, right? My sample proportion is my best guess at what everybody, the proportion of everybody would be. Okay. Sorry, you guys are quiet today. It's not, the test was fine, relax. All right. Mariah, go ahead.
The Pew Research Center conducted a survey of 1,007 adults and found that 85% of them know what Twitter is. The best point estimate would be the population proportion is the same as the sample proportion. P hat equals 0.85.
Great. Good. So population proportion means the population of everybody. The sample means the proportion I found from my little sample. Good. So make sure you don't mix those up. And again, the best guess of what everybody is whatever you got in your sample. Caleb. Caleb? Go ahead.
An interval estimate or confidence interval of a parameter is an interval or a range of values used to estimate the true value of a parameter P naught or mu. This estimate may or may not contain the value of the parameter being estimated.
Great. So, I'm going to drive to Oakland Airport at noon. How long do you think it will take if I average everybody's time it took to drive on a Thursday at noon from here to Oakland Airport? What do you think that average would be? What do you think? How long would it take to drive from here to Oakland Airport? 30 minutes? Who else?
35.
40? 35? What do you think?
40.
An hour.
An hour? Okay, so let's go with 35. Does that seem like a reasonable number?
Yes.
Okay, so my average here is 35. What do you think the odds are that the actual average is exactly 35?
Not very high.
Not very high.
Very high.
Right, it might be 34, it might be 35.3, it might be 30, 30, it might be 31, we don't know, right? 35. Okay, not super likely. But what if I gave a little window and said 30 minutes to 40 minutes? Now is it more likely that the actual average time is going to be in that range?
Yes.
Correct. What if I went a little further? 35, 25 to 35, 45 minutes. Do you think the actual average is even more likely to be in that range?
Yes.
I'm a little more confident. The larger range I take, the more confident I am that the actual mean will be in that range. Does that make sense? That's the idea of a confidence interval. We take our best guess, our p hat or our sample mean, and we take a little range around it this way and that way. We go a certain number of standard deviations this way, a certain number of standard deviations that way. sense? Do you guys remember, typically, roughly, 95% of my population falls within how many standard deviations on the mean? 2. So if I go 2 this way and 2 that way, about 95%. As we kind of learned at the end of last chapter, it's really 1.96 standard deviations this way and 1.96 standard deviations that way. Should be 95% of our data. So we're going to kind of go into more of that a little bit right now. Confidence interval is your statistic. So that would be like your p hat in this case, plus or minus a z-value. How many z-scores, however many z-scores, how many standard deviations you want to go in either direction. So this is your number of standard deviations multiplied by what a standard deviation is. All right, so that kind of makes sense. It's just saying I take my p hat, I figure out how many standard deviations I want to go in either direction, multiply that by a standard deviation, and that's how much I subtract or add from my mean to get my interval.
So Z value is the same thing as critical value?
Yeah.
'Cause
Awesome.
That's what it says right here, but up there
Yeah.
it says Z value.
Yeah, we're going to get to that, totally. Critical value is a z-value. So let's talk a little bit about confidence levels. How about Nolan? Go ahead.
The confidence level is the probability 1 minus
Alpha.
alpha
Uh-huh.
that the interval estimate will contain the parameter, assuming that a large number of samples are selected and the estimation process on the same parameter is repeated.
Great. So for 2 standard deviations, roughly 2 standard deviations either way, what percent of my data should be inside? If I go 2 standard deviations this way and 2 standard deviations that way?
1.96.
95% should be inside. Does that make sense? If I go 1.96 standard deviations this way and 1.96 standard deviations that way, 95% should be inside. That's my confidence level. What's on the outside? The rest. 95% is on the inside. How much is on the outside? 5%. That's my alpha. So alpha and my confidence level are they're kind of flips at each other, right? The confidence level is what's on the inside. Alpha is what's on the outside. Make sense? If I have a 90% confidence level, what's my alpha? 90% confidence level. Alpha is 10%. If I have an 80% confidence level, what's my alpha? 20%. Everybody good with that? Great. So let's talk about interpreting it. How about, it's a good long one. Salim, you up for it?
Yeah.
Great, do it.
Interpreting a confidence interval. We must be careful to interpret confidence intervals correctly. There is a correct interpretation and many different and creative incorrect interpretations of the confidence interval. 0.828
P is between?
P is between 0.872. We are 95% confident that the interval from 0.828 to 0.872 actually does contain the true value of the population proportion P.
Right, that'd be the correct way of saying it. Which one?
This means that if we were to select many different samples of size 1007 and construct the corresponding confidence intervals, 95% of them would actually contain the value of the population proportion P.
Right, so I'm doing a sample, finding a mean, taking confidence interval around that. Take another sample, find a mean, take the confidence interval around that. Take another sample, find the mean, take confidence interval around that. I do this over and over again a whole bunch of times. If I were to, right, I'll give you a picture. If I were to do that, then each one of these would be, every one of these red dots is a sample. That's a sample mean, that's a sample mean, that's a sample mean, that's a sample mean. These are all sample means. So every one of these represents a sample of 1007 or whatever, a sample of 35. and their average. Everyone has red dots. And then, we take an interval around that mean. An interval around that mean. Is that everybody out with me? If we do this over and over, if we were to do it over and over again, 95% of them would actually contain the real mean. But every once in a while, we'll take a weird sample. We don't know it's a weird sample, we've just taken a sample. Right, do you guys remember earlier in the semester when everybody flipped a coin 100 times on the computer and like two people got like 59 or more? They didn't know they had a weird sample, right? They did this experiment and they got this, they think that that's how it should always be. So those people are going to be the ones who write a paper. Do you guys remember the video on why most published papers are false?
Yeah.
Right, because people do an experiment, they get this great, different, unique result, and they don't realize they've taken a strange sample. They've gotten randomly a weird sample. So they're like, great, probability of heads is not 50%, it's really something higher. They write this published paper and then no one can reproduce it because they had a weird sample. So if you take a 95% confidence interval, then randomly, 5% of the time, you're going to get a weird sample. And that weird sample will not contain the actual mean. All right, critical values. Amanda.
Critical values. A standard z-score can be used to distinguish between sample statistics that are likely to occur and those that are unlikely to occur. Such a z-score is called a critical value. Critical values are based on the following observations. 1, under certain conditions, the sampling distribution of sample proportions can be approximated by a normal distribution. 2, a z-score associated with the sample proportion has a probability of alpha divided by 2 of falling in the right tail.
Right. So you know how we're going over so many standard deviations in either direction, right? To find that z value, we call that our critical value, like Carla pointed out. And the way we can use this is, do you guys remember central limit theorem? Means, I was like, what? Yeah. It means that even if our data isn't normally distributed, remember like that uniform distribution we found? If we take a sample of 30 or more and take their average, the mean of means, you guys remember that mean of means thing? So you take a sample, take the mean of that, take another sample, take the mean of that, take another sample, take the mean of that. Those means will form a normal distribution. And we take advantage of that because the means form a normal distribution. If we take a sample and take the mean of that and use that, then we can use this whole normal distribution and the fact that 95% of them should fall within 1.96 standard deviations of the mean, of the actual mean that we don't know. So we're going to go into that a little bit more. I'm going to talk about this whole z of alpha over 2. So here's my critical value. It is the same thing as the alpha over 2. So this line, this z-score that divides my usual values, my usual results from my unusual results. Right? What's our guideline for unusual? 5% or less, right? So that's the general generic guideline for unusual. So that'd be 95% on the inside, 5% on the outside. So our likely stuff, this is 95% on the inside. So all those z-scores that are, remember we talked about z-scores, the ones that are likely versus unlikely? And if we're within 2, if your z-score is between -2 and +2, you're kind of in that likely range. If your z-score is less than -2 or greater than +2, then you're in that unlikely range. So these are kind of our likely z-scores and our unlikely z-scores. Z alpha over 2 is the borderline. It's kind of the boundary kind of in a way between the likely and the unlikely ones. And that z alpha over 2, your book will call it z alpha over 2. You'll see that often. I call it critical value because that's one less thing to complicate and confuse people. So on the exams, everything else, in class we're going to call it critical value. Just know that sometimes when you see z alpha over 2, it's the same thing. So critical value is the z-score that separates the unlikely from the likely ones. Are we all right with that part? Why is it alpha over 2? If I have 95% on the inside, you know what, we're going to talk about that in just a minute. Let me not jump ahead. Alpha is this area here. It's a probability. What's another word for probability? Okay, so there's three things that are kind of similar. Probability is one of them. What's another thing?
Chance.
Chance. That's true. Probability is like the same thing as a chance. It was actually a credit question on the last exam.
Statistic.
Area. Probability and area and percent of population. Why are they? How do we know they're all the same thing? Because what? What do they all have in common? The sum of the probabilities always adds up to what? 1. The area underneath a distribution curve always adds up to what?
1.
If I have everybody in the population, that should add up to what?
100.
100%. 1. So you guys kind of follow me?
What is 100?
100% is 1. Okay, good. So alpha is a probability. So it's a what? In terms of this picture.
1.
Okay, don't think about that. Think about words.
1 minus A.
I'll give you some options. Statistics, area, z-score.
Area.
It's an area. Everybody all okay with this part? Okay. Give me thumbs. Like, totally got this, not so much.
Our sheet.
Okay. Alright.
I'm like, it's not on the sheet, but.
We'll look at the picture. Hold on.
I know all at once, right?
Okay, we are at
Also
the
find out
bottom
my
of the
calculator.
page. If I'm picking a 95% confidence interval, 95% on the inside, how much is on the outside? 5%. But that's split on either side. You guys understand what I'm saying? So if there's 5% on the outside, how much is in each tail? 2.5%. So again, remember, if my confidence level is on the inside, my alpha is the stuff on the outside. But half the alpha's in the right tail and half the alpha's in the left tail. So it's really half of alpha is in each tail. So see how it has the alpha over 2 equals 0.025? Right, because my alpha is 5%. Alpha divided in half, 0.025. That's where the z alpha over 2 comes from. It's the z-score where you have half of alpha in the tail. So we could do inverse norm of whatever that, of 0.02. Everyone get out calculators. Get it out. We're going to do inverse norm of 0.025.
I'll probably have to buy.
All right, inverse norm is where you feed it a left area and it gives you the z-score that goes with it. And then remember with the z alpha over 2s, we just take the absolute value of that. Usually, so here we go. Second, bars, right? Go down to inverse norm. And I want inverse norm of what's my area? Not 0.25, it's 2 cents, right? 2.5 cents, so 0.02, and then the rest of it. 2%, 2 cents. What do you guys get?
1.6.
Yep, if you round it, negative 1.96. Good. So that would be the z alpha over 2. Please note, this alpha over 2, everybody eyes here. Alpha over 2 is a label. Does not mean take z multiplied by alpha divided by 2. The alpha over 2 is just a label, like z of Johnny or z of Ralph, right? It's just a label. It's a z-score that goes with alpha over 2. Good? All right. And again, I'm just going to call those critical values in general. Your book will call them z of alpha over 2. I'm just going to call them critical values because that just keeps things nice and clean and clear and avoids extra confusion that we don't need. All right. here's the beautiful thing. For proportions, we're only going to have 4 different confidence levels. I might ask for a 90% one, a 95% one, which is kind of the most common, or sometimes people will ask for a 98 or 99% confidence level. If I have a 90% confidence level, what's my alpha? 10%. Everybody with me on that one? The z-score that goes with that, the critical value, is, well, let's use 95%. 95% confidence level, what's my alpha? 5%. What's a z-score that separates that 95% from everything else? 1.96. You guys know that one. For 90%, the z-score is 1.645. Yep. And
Can
for,
you also round the
yeah, since it's right on the 5, they usually kind of leave it.
Okay.
Yeah.
So don't round
You
the
can.
test?
Yeah, you can. That'd be all right. If you round it to 2 decimals, that'd be all right. Yeah.
So the critical value is, so it's gonna be, like, for example, it's 99%, it's gonna be 2.575 on both sides?
Yeah, it'd be positive
Negative
2.5. So on the left side, right, here's my middle. What's my z-score right in the middle? 0.
0.
If I go 2.575 standard deviations this way, what's the z-score going to be?
Negative.
Negative 2.575. If I go 2.575 standard deviations this way, my z-score is going to be positive 2.575. Make sense? Good. Great questions. Thanks, Raf.